Okay, so for these notes, we're going to focus on division and finding the zeros of a function or a polynomial. We're going to start with some general information. For example, this equation here, h of x, it's a polynomial of a degree 4. So that means using the theorem that we will more than likely have 4 roots. Some of them could be real, some of them would be complex. And they do give you some information. They say x minus 2 is a factor. What that means is that if I have x minus 2 equal to 0 and I add 2 to both sides, I get x equals 2 being one of my roots. So my graph is a degree 4 and the leading coefficient is a positive 2. So because it has a positive 2, that means both arrows go up. So maybe my graph looks something like this. It's a rough sketch. I don't really know what it really looks like, but I do know that because x minus 2 is a factor, I do have a root here at x equals 2. That means that my y value, or actually my h value, my function at that point, the value is 0. So h of 2 is equal to 0. So 1, 0 of this equation, or this polynomial, is x equals 2. Since I know that, I can use that root or that factor to divide my polynomial and find the other roots or the other factors. So I like synthetic division, and because x minus 2 is a simple factor, there's no coefficient in front of x, I can do synthetic division. Or for synthetic division, your house number has to be the actual root or the opposite of the factor. So instead of saying x minus 2 or it's minus 2, it's positive 2. It's actually the root, the 0. So I'm going to start with the 2. That's my house number. It was on the outside. And then on the inside, we do the coefficients and make sure that we don't skip any exponents. So we go from 2, 4, 3, 2, 1, nothing. So it looks like I do have standard form. So I just need to bring out the coefficients. I got 2, 3, negative 14, negative 9, and 18. We bring down the first number. The number on the outside always multiplies with the house number. So 2 times 2 gives me 4. 4 goes on the inside. Inside we add straight down. I get 7. 7's on the outside. The outside always multiplies with the house number, which is 2. I get 14. That goes on the inside. Inside, I add straight down. I get 0. 0 goes on the outside. Outside, I multiply with the house number and get 0. We add straight down, get negative 9. Negative 9 is on the outside. Outside, we multiply with the house number. That's going to be negative 18. And then we're going to add straight down one more time. That gives me a 0. So again, this proves that because my remainder is 0, x minus 2 is a factor, kind of like when you divide 6 by 2. You get a remainder of 0 because 2 is a factor. So my other factor, this is a remainder. And then we kind of go backwards from there. We start with the constant, x1, x2, x3. So this is my constant, x1, x2, x3. So I have 2x cubed plus 7x squared. I don't really need this part, minus 9. Or I would need it if I am doing synthetic division again. And this is my other factor. So these are my factors that are equal to 0. This 2 factors is the same thing as this polynomial. So from here, I have a few options. I can try to factor this polynomial, my new factor, 2x cubed plus 7x squared minus 9. I can try and do maybe a grouping method, but I don't think it works with a 0. So instead, I'm going to use the theorem. It's the fundamental theorem of algebra. Basically, you have a leading coefficient, which was 2. And you have your constant, which is 18. You look for all the factors of your constant. So for 18, it's 1 times 18, 2 times 9, 3 times 6. And you look for all, that's my constant, for all the factors of your leading coefficient for 2, which is 2 times 1. And then what you do is you put all of your factors of the constant on top of all the factors of the leading coefficient. We're going to start with 1. We're going to put 1 on top of 2, and then 1 on top of 1. So, or I guess we can start with 1 first. 1 and 2. And they're both positive and negative. And we do the same thing for all the numbers on the constant side on top of these numbers. So we're going to put 2 on top of 1, and then 2 on top of 2. So 2 on top of 1, that's 2. And 2 on top of 2. And so I took care of this number and this number, so I do the same thing for the 3. 3 goes on top of 1, and 3 goes on top of 2. So again, I'm getting these numbers from here. The denominators come from the leading coefficient. And then the numerators come from the constant. And we do both positive and negative because these are all the possible roots. Notice this could take some time because I can still add more numbers, but this number is the same as this number. They're both 1, so you don't have to write them twice. But it's important to list them first so that then you can cancel out the ones that you haven't multiple times. I notice the 2 is an actual root, so that one we know it's for sure. You have to like guess and check to see which one is an actual root. I'm gonna start with 1 because it's like the first obvious guess. Always check positive 1 and negative 1 and then go from there. So I'm gonna check positive 1 first, and again I'm gonna use the coefficients that I got from my new factor, which is 2, 7, 0, and negative 9. Bring down. Now that's on the outside. When I have a number on the outside, I need to multiply it with my house number, which I am guessing is 1. That's my next root. I get 2. Add straight down, I get 9. Multiply with the 1, I get 9. Add straight down, I get 9. Multiply with the house number again, I get 9. Add straight down, and luckily for me, my remainder is 4. That means this worked. That means x minus 1 is a factor because I got a remainder of 0. And that means this is my constant, x1, x2, 2x squared plus 9x plus 9 is another factor. So right now, if I'm factoring completely, I currently have x minus 2, x minus 1, 2x squared plus 9x plus 9. I'm still looking for all the zeros, so I haven't found all of them yet because I haven't found all the factors. I still need to factor this out. And because it's a quadratic, it's x squared. I'm going to try to go easy and hopefully this works. 18 and 9, what numbers can I multiply? If this is A, B, and C, I try to do the x puzzle, x squared, multiply 8 times C, 2 times 9, that gave me 18. B value is 9. What numbers can I multiply to get 18 but add up to get 9? I think that's 6 and 3. So my other factors would be x plus 6, x plus 3. So I did see the 3 was right here, and then eventually you would put 6 on top of 1. So that's where the other factor comes from. So my roots, remember we're going to change the sign. We already knew one of the roots was 2 because we had already found it. The other one was 1 because it's the one we guessed that did work. So we have 2, x equals 2, positive 1. For these two, we're going to change the sign because, again, we have x minus 6 as a factor. But when we solve for x, we end up with a positive 6. So we basically change the sign. So those are my other roots. And that's how we find the roots of a polynomial without using decimals.